The Mimeo Studio needs to be calibrated. I'll do the best I can. Well, it's not that bad, but it's off a little bit. Okay, so today we're going to start. We'll do some more programming in a little while, but today we're going to start by talking about what the essential difference is between object-oriented programming and non-object-oriented programming. So first I wanted to start with the way I like to try to describe, and I'm sure that you did some of this in data structures, the difference between a class versus an object. Okay? So if you didn't take data structures here, this might be a useful discussion. Unless you've done a lot of work already with OO, you probably know all this. So the idea is, I've got these cards here, and of course they're all actually something. Okay, whatever they happen to be doesn't really matter. So what I'm going to claim is if I have them face down like this, where you can see the backs, but you don't know exactly what the card is, that can be our mental picture of what the idea behind a class is supposed to be. Because even though we don't know what those cards are, is there any features that we know, if I tell you it's part of a 52 card standard playing deck, what do you know that they're going to have on the other sides, even though you don't know specifically what is going to be on the other side?
One of four symbols.
So yeah, we're going to have a suit.
And a value?
And a value. Okay? So if we were getting ready to design a card class, we would have two variables. One of them would be corresponding to the suit, whether we decide to use text to represent the suit or an integer 1 through 4, whatever the case may be. We're going to assign a variable to represent the suit, and we're also going to assign a variable to represent the value. Okay? Again, so we're going to have to figure out something for handling the jack, queen, king, and ace, but we probably could use all integers for that too. Okay, or we could, assign them to both be strings, however we decide to do that. But nevertheless, we know each one of those cards is going to have a suit and a value. So when I design a card class, I'm going to list those variables, those properties that thing is supposed to have, but I'm not actually going to give them specific values. So that would correspond to seeing the back of the cards. You know it's a 52 card playing deck, you know it's got a suit and a value. But you don't know exactly what they are for any particular card at this point. Okay? So when we decide, programming wise, we're going to write that class out, we're going to provide a variable for suit, a variable for value. In another class, the one that's supposed to be building the entire 52 card deck, we're going to have to start creating actual cards and assigning values for both the suit and the value. Okay? And so that would correspond to us going through the deck and creating a jack of clubs, creating a queen of clubs, creating an ace of spades, and then all the other cards too. Okay? So if we wanted a complete deck, we would one by one create cards where I pick a particular suit and a particular value to give to each and every card. And if I create a standard 52 card playing deck, we know how that works. Okay? Now I may want to come up with my own deck that's got some duplicates or fewer suits or a different range of values. That would be fine too. But if we're creating a standard 52 card playing deck, that would correspond to us assigning appropriate suit and values for 52 separate card objects. Okay? So a class, we declare the variables, but we don't actually give them values. For an object, we specify what those variables are supposed to be. Okay? So now, with that short exercise done, let's talk about what the difference between object-oriented programming, where we're going to be using those classes and those objects extensively, versus non-OO. If we were to boil it down to we could actually compare lots of different things. But if we go to the very heart of the matter, what the primary difference between these techniques are, it's this. So non-OO has global data that needs to be passed around to subroutines, procedures or subroutines. Okay? Whereas OO, as we just saw, we're going to create 52 separate cards, and they're all going to be responsible for their own data. Okay? So the data is decentralized. It's dispersed amongst the various objects of a particular class. Okay? So this has some built-in advantages. Of course, I'm not going to claim that OO is, solves all the world's problems, because of course it doesn't. There's certainly a lot of good things about regular old C procedural style programming. Okay? But there are, yeah.
Sorry, what's that word?
Last one.
Decentralized. Yeah, not only, even today, it's going to be even worse than my normal horrible handwriting, because it's not correctly calibrated. Okay, fortunately, 3 of my 4 classes are in 206, which didn't have any problems. And the desk is tilted. So, glad this is the only class I have in here right now. Okay? So, that builds in some nice features. But again, we could discuss some of the, the problems with OO, which it certainly has. Okay? So what are the nice features? Since in this class we're learning object-oriented programming. So the good thing about OO programming, the fact that the data is decentralized. Well, let's talk about what would happen if I change my mind in a non-OO environment about how I want to store the data. Okay? So in non-OO, suppose we change how our global data, we change what the global data is. Let's even change that. We may change our mind exactly how and what we want to store at some point. In fact, we're going to. It's almost a guarantee. That's why we talked about Agile last time. Okay? We know things are going to change. The customer's going to change their mind. What kind of impact is that going to have on us if that does happen? Well, unfortunately, depending upon how much software we've actually written, if we haven't written very much, we're fine. But suppose we've written a bunch of procedures. Okay? And now we're changing what's stored and how it's going to be stored. Well, that means we may very well have to change all the procedures that use that data. Okay? Not a really good situation. So the problem with that is, so this may result in a lot of our code changing. Okay? And that's certainly a bad thing from the perspective of trying to get a project finished, because now we got to go and rewrite those procedures to use the new data format of the data, which of course could also result in, which is almost certainly going to result in more bugs that we're going to have to fix. Okay? So, what does, by the fact that we decentralize our data in an OO environment, there is no global data. It's the individual components that are storing their own stuff that belongs to them. Okay? What does that buy us? Okay? It's a couple of things. By not having a whole bunch of global data, if I look at a particular section of my program, which may correspond to a couple of different types of objects, and if I've designed my classes well, I'm going to understand the stuff that's being stored in those objects. It's readable. If I'm looking at a card class and I see a suit and a value, I'm going to have a pretty good idea what's going on there. Okay? If I have to pass those down from some kind of global data source, it may be more difficult, access a particular component of the data, and may be a little bit more difficult to understand what's going on. Okay? So that's the main thing. We talked about, last time we talked about functional quality and code quality. Do you think readable code is more of a functional quality thing or a code quality thing? Code quality. Okay? So we can certainly have completely unreadable code that works. We don't really want that because it's not maintainable. So the next thing about the fact that we're making code that's readable, as a byproduct of that readability, it's also maintainable. We can go back several months or years later, and since we made the code readable, we understand what's going on in it. We can make any necessary changes. Okay? And then it's also going to be reusable. Essentially because of those first two reasons as well. It's readable, we understand it, it's easily, we can change it to new situations, which means we're going to be able to use it in new projects. Okay? So the whole idea here is to when we make changes, because we know we're going to have to, okay, that was what we talked about last time, the agile software development. How much is that going to, how much extra work is that going to incur? Okay? If we have a bunch of classes that keep track of their own data, when I make a change to a particular data component, I can change just the associated class. Okay? I don't have to worry about the rest of the project. Whereas if I've got global data that I'm passing around, and I change the way that data is stored, who knows how much I have to change in my other program. Okay? So those are really the reasons why OO has become and is still reasonably popular. It's because of essentially because the decentralized data leads to these code quality things. Okay? Well, of course, it still has to work. So we need functional quality, which the primary component of that is reliability, which we'll talk about in a later class. Okay? But OO does build in for us, if we get good at designing projects using the OO techniques, it builds in some code quality. Okay? Because it keeps things in there, and also it keeps the data in separate units. All right. I think we're done with that. So let's go back to our code. I didn't really want to have to write any more anyway, since it's difficult to write today on this thing. Okay, so I think we pretty much, there wasn't much going on in this driver. The main thing I wanted to show you about that is the way that you can get input from a file. Okay, and you can also redirect your output to a file as well. That's a shortcut that has saved me a lot of time, especially when I'm grading your programs, because when it comes time for me to grade your programs, in the first program there's a lot of input to it. Okay? I would never finish, there's 70 of you, if I had to type in all the different things that I need to do in that first program for each and every one of you. First of all, that would take forever. Secondly, I'm going to make mistakes and have to start over. Okay? So the most efficient way for me to do that, to get all the input into your program, is to type it in once in a text file and just copy that text file into everybody's folder. Okay? So that's what I'm going to do. That trick I showed you last time is actually pretty useful. All right, so let's move on and do some other new stuff with a different driver. So I want to start, since we're talking about OO versus non-OO, let's start doing some OO stuff. Probably nothing that you don't remember from data structures. So I want to create, so I've got this rational number class, which we'll dissect either later today or next time. We'll look in the more detail of what's going on inside there. But the idea is we have one integer, a rational number is one integer divided by another integer. Okay? So if I look into a couple of ways I can figure out how to use my rational number class is I can actually look at the source code, which is not ideal. Okay, because in particular, in many cases, you won't have access to the source code. So you would expect to have some documentation online that you can refer to figure out how to use a particular class. Okay? We'll talk about how to do that. There's a JavaDoc tool, which is probably similar to what I don't even remember what it's called in C++, but you probably did something like that. Doxygen? Does that sound familiar to anybody? Okay, that's an automated commenting tool that goes through and finds all the methods that you write in a class and puts them in a nice HTML document for you to refer to later, or anyone to refer to. Okay? There's a similar tool for Java called JavaDoc. But for now, since we haven't done that stuff yet, I'm going to do the more tedious way of looking at the source file to find out what's available. Okay? So anything that's listed as public, that's something that any other class is able to call. So just like in data structures, when you had constructors, we've got constructors in Java. Okay? There are a few rules we have to follow, but let's not worry about. So I just want to look at the public procedures and use them. Okay? We'll dissect the other stuff that's going on in here next time. So I see I've got a constructor that takes a numerator and denominator. So let's just go ahead and make use of that. The way that you create new objects in Java is you use a new keyword. Okay? But in C++, you were used to, whenever you used a new keyword, that meant you were creating a pointer to something. Well, in Java, anytime that you're using anything beyond the primitives like integers and floats and characters, okay? Anytime you're using anything that's more complex than that, you are always using pointers. Okay, so the vast majority of time in here, we're going to be using pointers. Java doesn't call them pointers, and we don't use asterisks anymore. They're called references, but it's a pointer. Okay, it's actually not quite the same as what you probably discussed with a reference in C++, which is, well, we don't need to do C++ in here. They're called references, so if you look online, they're going to talk about Java references, but in fact, it's really a pointer. Okay? So what I've done here in this line is I've created a rational number with the numerator set to 2 and the denominator set to 3. Okay? So if I try to draw a picture of what's going on in that code, and I like to make you all do some of this on your first exam. I'll probably have you draw some pictures. Oops, what did I call it? rn1. So I have a variable called rn1, and it's a pointer, so what is that variable going to contain? It's going to contain a memory address. So whatever that mem address is, we don't really care. Okay? So that's setting up the left-hand side. I've got rn1 that's going to contain a memory address. On the right-hand side of my assignment statement, I'm going to create a new object, a rational number object, where I've specified what those variables are. So remember our card example. When I'm writing the class, I just list the things that I declare variables for the data that thing is supposed to hold, and I leave it generic. That's the class. I turn it into an object when I pick particular values for the numerator and the denominator, and that's done through the constructor. So back over here, I now create something with a numerator equal to 2 and a denominator equal to 3. I put it somewhere in memory where those two values are going to be stored. And what new does is it returns a value. Okay, new is an operator, it returns a value, and that value is the memory address of where that thing got created in memory. Okay? So that value gets copied into rn1. That's what the assignment statement does. New returns a memory address, which we used an assignment statement to place that result in rn1. Okay? So I want to now no longer have to worry about writing a box with memory address in it. The way that I'm going to represent that in diagrams is with an arrow. Okay, it's a pointer. So RN1 points to the memory location that has two variables of storage. One of them has the value 2 stored in it. The other one has the value 3 stored in it. Is that okay? All right. Hopefully that's not totally new stuff. So what happens here in RN2? It's the same song and dance. I'm going to declare a new variable that's going to hold a memory address. On the right-hand side, I store 5 and 6. I return the memory address of where that storage was actually placed. Okay, we've got a 5 and 6. All right. The next thing I do, and I would probably need to look inside rational number. What kind of other stuff can I do here? I've got other constructors. Here's an add method. The add method says, give me a rational number. I'm going to add a couple of things together and return a new rational number that corresponds to the sum of those two rational numbers. Okay? So let's try to do that operation. Let's see. I want to go here first. Okay? So I'm going to call the add method on RN1. I'm going to pass it the rational number 2. That procedure is supposed to find the common denominator and do all that other jazz, and return to me a rational number that corresponds to the result. So in our picture, we declare a variable called RN3, which is again going to be a memory address, a pointer. It's getting worse, I think. And what it's going to store is, so we had 2/3, we've got 4/6 plus 5/6, which is 9/6. Okay, and I think it also has some code in there that will simplify the fraction if it can be simplified. So it's actually going to store this as 3/2 or 1.5. Okay, and now there's a couple of ways that we could have written that. We could have had it replace, so it's difficult to tell from the code by itself. Let's see here. There's a couple of things that could have happened here. The code could have changed the values. I could have accessed RN1's 2/3 value and simply changed them to be new values. Okay? That's a bad technique. What I've done here is the best way to do that. So I'm not going to do it. I'm inside the RN1's add method. We don't change the values that are stored in R1. They're going to stay 2/3. Okay? We're going to do that addition. We're going to grab the 2/3 and the 5/6 and find common denominators. But before we leave the add method, we're going to create a brand new rational number. Okay? And store the result of the addition in the new one. So that's why in my diagram, because I knew that's how I actually did it, we have a third value which points to the new numbers. Okay? That's a good technique to use. It has a name. It's called, I don't know if I can write it up here with this thing being so off. It's gotten steadily worse. Those are immutable objects. Okay, and the first several objects that we deal with in this class, including this one and strings, which we'll talk about in just a second, they're immutable. That means once I create this rational number, there is no way for me to go in there and change that 2 and that 3 to anything else. It's impossible. The way we're going to design that class next time when we look at how it's actually done, we're going to see that we made it impossible to change that 2 and that 3. Okay? So if I need a new rational number, I'm going to have to store it in a new variable. Okay? So that's the way we're going to do our first several sets of objects, and it's going to look like this picture. So I do go ahead and I take the 2/3 and I add the 5/6 to it and I get the new numbers, but I don't change RN1's or RN2's values. I create a new rational number. In fact, let's go ahead and peek at it here. So at the bottom of the add method, I create a new rational number and return it. But there's nothing that I could easily have simply changed these numbers here at the top from what they were stored as. Okay? So the first design technique that we've learned in here is if it's possible for you to create an immutable object, that's the way you should do it. It's much easier to debug something, if there's a problem with our class, to debug it if the only way that you can change its values is by creating a new object. It just turns out that's easier to deal with. Okay? Now, not all objects does it make sense to make them immutable. Sometimes you have to change the values. But to the largest extent possible, we should design stuff like this, so that this picture corresponds to what's actually going on. Okay? What if I really, really, really wanted to change RN1 so it had new values? Okay? Let's see. Let's go back here and see if we can do that. I could have done, instead of this line here, I could have said this. Whoops, I don't want to redeclare it though. Okay? I still created a brand new object. I didn't mess with the 2/3 that RN1 used to point to. All I've done there is modified my diagram a little bit so that it looks like this. And there's no RN3 anymore. Okay? RN1, the memory address that it pointed to is now to that new object that I created, and I abandoned the old one. What did you have to do in C++?
Delete it.
You have to delete it. In Java, you don't have to delete anything. Okay? It's got something called automatic garbage collection. Every once in a while, a new process is going to start up to look around at the memory that you've allocated in your program and see if that memory address, if any variables have it. If there are no variables with that memory address where that stuff is, you can't get back to it. It's impossible. Okay? So it's going to go ahead and just free up that space. It's going to let that space be used to store new values for some other object. Okay? So that's going to get garbage collected simply because I abandoned it. Okay? So if I really don't want to have a brand new variable and I'm dealing with immutable objects like we are right here, that's okay. You're just going to have your pointer point to the new stuff and then let the old stuff be garbage collected. Okay? Let's do a little bit of work with strings, which work exactly the same way. They're immutable objects too. Let's just put some strings in here. Let me comment this out. We're not ready for that. Okay? So create a new string. It's going to hold an array of characters, in this case A, B, C, and it's going to return to me the memory address, which then str will point to. Okay? The string class also has immutable objects. I can't change the contents of this thing. I can only point the pointer if I want to change. If I wanted to make it look like my pointer points to a new string, I have to create a brand new one and abandon the old one, which will be garbage collected. Okay? So even if I try to do something like this, let's see, stir is equal to stir.append, I don't know, something. So what that, much like the rational number addition that we did a few minutes ago, it's going to take the contents that are stored in str, which is ABC. It's going to tack on a bunch of new characters. It's going to put it in a new memory location and return the new memory address, which then str will point to. Okay, so this is also an example of an immutable class, and it's one that we're going to use a lot. In fact, I guess we should go ahead and talk about the fact that strings are in between primitives and objects. So as I said a little while ago, primitives are integers, doubles, characters, booleans. Strings have a special place, sort of. They're part primitive and part object. How are they part primitive? You can do something like this. Okay? So behind the scenes, these are treated a little bit differently. But normally, the only time that you aren't going to be using new to create a new object is with primitives. Okay? Strings can either be treated like a primitive, as I've done here. What's that? Okay. Primitive like I've done there, or like an object. And there are some subtle differences in the way your program can run based on which one of these you use, but we'll get to that later. Okay? The main thing here is you're going to see online and in the examples, you're going to see both ways of creating strings. Okay? But the main thing is, remember that strings are immutable. It is impossible to change the contents of a string after you've created it. You have to create a new one and point the old one to the new memory location if you want to change its contents. Okay? And then let the old one be garbage collected. Okay. Let's make sure this thing actually works. So we expect our answer to be, oh, I need to print it out though. If I want to print the contents of my workout, then I use system out println. All objects have a toString method. In particular, my rational number has a toString method. So in fact, what I'm actually calling, okay, I'm saying take the current object and the values that are stored for its numerator and denominator, convert that to text. That's what toString does. And then system out println says print that text out to the screen. Or if we redirected it to an output file, it would be sent to a file. Okay? But that happens automatically, so I can actually be lazy and simply say system.out.println rn1. It automatically calls the toString method and prints the contents of that string out. Let's see if that will actually run. Okay, it looks like it's saved. Okay, it printed out 1.5 because I actually had the toString method do a little bit of extra work. I could have just said print out the numerator, which was 3, and the denominator, which was 2. Okay, I could have done that. But instead, I put some extra code in there that had it figure out whether there was a whole number component as well. So it printed out 1.5. Okay? But generally speaking, this is going to be a useful debug tool because what system.out.println is supposed to do is print out the state of the object. What is the state of the object? Well, in the case of a card, it's what the suit and the number in the suit are. In the case of a rational number, it's what the numerator and denominator are. stretch or question? That's a stretch, I guess. Okay? So it's a useful debug tool. If you're debugging, you've written a class, you want to test your object out, you create some of them, you want to know what's being stored in it, you can write a toString method to print out what those variables are, and then you can follow the state of that object. Okay? So real helpful method to write for all of the objects that you create. You should always have a toString method. Okay? Now, let's go down to the second bit here. So, since we all just got out of data structures, of course, which is about collections, we're going to be doing a lot with collection classes in here. Okay? So, you're never going to get rid of data structures. It's always going to be super important. And in here, it's going to be super important as well. So, that's what the rational numbers class is all about. I'm going to keep track of a bunch of rational numbers. So maybe I store them in an array. Maybe I store them in a linked list. Maybe I store them in a hash table, a tree, whatever the case may be. Okay? I'm pretty sure that mine are just in an array. But I want to add all three of our rational numbers, so we need to go back to this one here. I want to now add them all to that collection and display all the numbers that are in the collection. So have a loop that calls their toString methods. And then also have another procedure inside the rational numbers class that's going to sum them all together. Add the first one plus the second one, add that result to the third one, etc. Okay? And then that's going to give us a new rational number, and then print out that final result. Okay? So let's make sure that works. And in fact, we can go ahead and open up the rational number class and see that it's up. So it's using an array list. Where is the constructor? There it is. I just create an empty array list. And then whenever they add one to it, okay, I just add it to the array list. And whenever they want to sum them all up, I loop over the array list and I get them all out and add them together. Okay? Oh, by the way, array list is a built-in data structure in Java, which we are going to use a lot. Does anybody remember why is list array frequently more useful than some kind of linked list structure? To review some data structures.
Quicker retrieval.
Yes. The get, in particular, there's a get method. If I want to be able to just grab individual elements out of there, with an array list, I can jump right to the index, okay, and get that element. With a linked list, I got to start at the head and loop all the way through to that element. Okay? So there's going to be a whole heck of a lot of our objects in this class, the collection classes themselves, that are going to make use of array list for that reason. Every once in a while, we might want to use a linked list, or a tree for, particular purposes. But certainly in this case, I just want to store a bunch of rational numbers. I don't need anything more sophisticated than a list. And I'm going to select array list because it has the fast get method. There also is there's a whole bunch of built-in ones. Linked list is one of them, so we could have done this using a linked list. Okay? But it would have been slower if I want to get out particular rational numbers. Okay. Let's go back. And I think that I save. Yes. Let's try this. So our new version now should not only print out 1.5 because we're still printing out, RN3 there. But now it's going to add them all up again. So we already know that these first two added together is 1.5. Well, what's 1.5 plus 1.5? 3. So we expect to get an even whole number as our result. Okay? So it printed out our old result. Then I also told it to display each and every rational number that we put in the array list, which it then did that. And then finally I added them all together and we got our 3. Okay? So very simple collection class. All right, so what happened when we created irrational numbers? Let's draw that picture. We created an empty array list. Okay, however big that is, I think we can specify if we want a starting size, but of course you guys know, whatever the size is, if we fill it up, it's going to automatically resize. So the built-in array list does all that important stuff that you did in data structures. Okay, so I called this thing rats, and I pointed to it with a variable. And then we put some stuff in it. We added rn1, rn2, and rn3. So I'm tempted to just go ahead and say, okay, here's rn1. But that's not, hopefully you guys remember, it's not that simple. What do I actually technically have to put in that first box? It's a memory address, right? Everything's a pointer unless we're dealing with integers and doubles and characters and booleans. Okay? So what I actually place in there is a memory address, which we know how to refer to that. It points to rn1, which was actually, it points to the data of rn1, which was 2/3. That one's going to point somewhere else to the 5/6, and that's going to point somewhere else to the 3/2. Okay, and then we got some unused space. All right, so we've got pointers pointing everywhere. They're probably actually all nice and lined in memory, but the general case, they don't have to be. In general, they could, it's wherever new finds some space to put that thing, that's the memory address it's going to return. Okay, so they're probably all nice and together in memory, but in the general case, they could be completely scattered. All right, and also remember, rn1 points to that thing, rn2 points to that one, and rn3 points to that one. So why is another good thing about immutability? If my object is not immutable, I could follow my reference to rn1 in there and change its numerator and denominator, and that's going to possibly break what I was doing with my rats. Okay? But with immutable objects, there's no way the user can't change the numerator and denominator without creating a brand new object. And what's that going to do? Nothing. Let's just say xy. We create an rn. Let's say that we tried to change the contents of rn1. And as you guys know, what really happened is rn1 points to the new thing. Okay? So as far as rats is concerned, everything still works. There was no way for the user to get in there and mess up the contents of the thing that was stored in that list array. Okay? The user thought they were doing that, and they actually weren't. They created a new object and pointed to it. And it's not even in. We didn't even put that in the rats array, so the rats array is completely unaffected. All right. Let's put the rn1 back. Questions about that? Okay, so unfortunately for y'all, all the data structures that you learned last semester are still going to be relevant this semester, with the one change that now we're using a slightly different syntax in Java. All right. Now, at the top here, I did a bunch of imports because next time we're going to be focusing on, we may even get started today, on text files. Okay, so I've got some classes already written inside the util folder that are going to let us read and write text files pretty easily. But another important one, we discussed keyboard last time. Another important one is a random number generator. So the ones I like to cover at the beginning of the class are the keyboard class, which we did briefly last time. where all you have to do is tell it you want an integer, and it'll get the integer from the keyboard. Tell it you want a floating point number, you get a double from the keyboard, etc. There's also a get string, will let you get a string from the keyboard. Okay? Likewise, I would like my random number generator to be as simple as possible. So, again, I'm going to use abstraction. Remember the key, I mentioned something called the scanner class, which you guys are really not supposed to know about. But you're going to see it. Okay? When you start working on your programs or your labs and you go out to the web, you're going to see the scanner class. And that does keyboard input and output. But it's a lot more difficult to use than mine. So I abstracted out some of the, in fact, there's a lot of concepts that we haven't talked about yet that you would need to be familiar with to use scanner class. Okay? So if I'm grading your programs and I see a bunch of exception handling with try catches, I'm going to know that you ignored me about what I said about the keyboard class. Okay? You're going to come to my office, you can say, how do I deal with this try catch thing, which, you know, is way down the road for now. And I'm going to say, aha, you're using the scanner class. Change it back to the keyboard class and come back. Okay? So the idea was the keyboard class was written to hide the complexity of the scanner class, more appropriate for the first and second and third day of class in here. Now eventually we'll have all the concepts that we need to understand scanner, but right now we don't. Okay? So I used something which actually got a name. When I hid the scanner class details from you inside the keyboard class, I used the facade design pattern. Okay? I'm using scanner, but I put up a facade in front of it and create a much more simpler interface for you guys to use to get your keyboard input. Okay? So that's one of the simplest design patterns and one of the most important because computer science is all about abstraction. Okay? You build classes on top of other classes on top of other classes. If you had to keep track of, if you had to keep in your mind how all that stuff worked, kind of like passing the global data around, your productivity would go to zero. Okay? So the fact that once you get something working and you can use it somewhere else, bug-free, or close to bug-free, that's going to increase your productivity. You can now forget about how that worked and start doing more complicated stuff. And that's what facade is all about. And oh, by the way, that's what random is all about. There's a random number generator in Java. Okay? It's a lot easier to use than scanner. So what I'm going to say is less applicable than what I was talking about with scanner. Okay? We could use it. But I've done the same thing with random numbers that I just mentioned with keyboard class. I hid the actual built-in Java random number generator inside another class, and this one's called random, and that's why I imported it here. Okay, another class in the util package that hides the built-in random number generator. So it's got a pretty easy to use interface. You can get a random integer by using the random int method, and you can get a random float. I think it's either random float or random double, something like that. Okay, these are all well documented. At some point in the labs, you'll have documentation for all these classes. Okay, the thing that I like about my version is I made it so I can give two integers, 56 and 87 in this case, and a random integer is going to be created in that interval inclusive of the two endpoints. So let's try that out. So hopefully we'll get something between 56 and 87, but who knows? Okay, we got a 72. So that worked. What if I want to generate a random? So you can do that with the built-in random number generator, but you've got to finagle with it to make it obey that integer range, that arbitrary integer range. Okay? It's expecting some standard range of stuff which you then have to adjust if you want an arbitrary range. So there's a couple of mathematical conversions that you need to do, which I plunked down inside that class and hid from you. Okay? If you want some kind of boring range like 1 to 100, you still have that. Okay? But now you've got the flexibility of generating random numbers in any other range. for integers. We can do the same for floats. I don't know if it's random float or random double. I guess we'll find out. And let's say we want a random float between 82.7 and 93.4. And then we need to print it. Okay, it's probably not random float. Oh yeah, actually it might be. Okay, so this is actually a good point. So I haven't talked much about primitives yet. We're pretty much the way we're going to handle primitives is as they come up, we'll cover them. Well, here's something came up. As you probably, what is that? As you probably remember from C++, if you just type a number in like that, it's treated as a double. Okay? Frequently, however, once you get more and more advanced in your programming skills, you're going to want to use floats where it's appropriate to use floats and doubles when you need to. In graphics, we can usually get away. We're dealing with floating point numbers all the time, doing lots of computations. If we can get away with the smaller size of a float, if we don't actually need an entire 64 bits for a double, we should do that. Well, 82.7 by itself is a double. So I need to put an F on there so it gets treated as a float. Okay, so now I'm going to have to give up and go look at what the method is actually called to make sure I'm giving it the right types. All right, there is a random float which takes two integers. Well, that's unfortunate. I don't think I would have ever guessed that. Okay. So random float and it returns a double. Okay. So let's say we want a random float between 82 and 93. Oh, so we got 89.55 something. Yeah, that's in that range. Let's try again. 88 point something. And we also got a random integer in the range 4 to 16, inclusive of the endpoints. So getting a 4 there is fine. See ya.